So this is week 58 quiz, and number 7 says, in pentagon ABCD, AB equals BC equals 10 square root 3, CD equals AE equals 20, angle A equals angle C equals 120 degrees, and angle B equals 90 degrees. What is the area of ABCD? Express your answer to the nearest whole number. So let's create a pentagon here. And so we are given that, what size is this? Okay. So let's create a pentagon. So let's say AB equals BC. So this is A, this is A, B, C. And this equals 10 root 3 and 10 root 3. And we are also given that angle B is 90 degrees. So we'll put that as 90 degrees. And then to make it easier, we'll just make this a triangle right here. And then we know that CD equals AE equals 20. And angle A equals angle C equals 120 degrees. So we also know that because it's a right triangle and it's isosceles, so these two are both 45. And we know that angle A equals angle C equals 120 degrees. So we know that the other part of angle A would equal to 120 degrees. 75 degrees. And so we'll make it like this, 75. Oh, wait, no, this does not look like 75. 75 and 75. And then we draw that here. So this is 20 and this is 20. And our goal is to find what is the area of A, B, C, D, E. So we begin by, well, we see that this is a right angle, like right here. And so we're thinking like a rectangle. And it'd be so nice if like this thing could like fit in a rectangle like this. And so we make it fit in a rectangle. Because we know there is one that exists out there somewhere. And wait, let me erase this real quick. And one that's like touching out all of the angles, like right here and right here. And so now we're trying to find what these are. And we also know that these are all right angles. So we see that this triangle over here. Oh, I forgot to label D and E here. And so we see that this triangle over here that I'm like focusing on like right now. This triangle over here is a 30, 60, 90 triangle. 60 because it's a supplementary angle to the 120 degree one, and 30. And so this is going to be equal to 10 root 3 because it's the angle opposite 60, and this is equal to 10. And same thing over here, it's just 10 root 3, and this is 10. And so then we know that this is 10 and this is 10, I think. Because we're just like, why is this drawn so bad? Because we're just kind of like sliding it over. Like, this is a better one. Nope, it's not. Let me like redraw this for a second. Okay, here. And we know this is 10 and this is 10 because we're pretty much just like sliding over this part. And we're just like bringing this part over here. Or like a better explanation would be that because it's a rectangle, this side over here is equal to this side over here, and we already know this is 10 root 3, so this will be 10, and same logic for the other side. Why is it erasing partials? And so now we can see that. And this is 10, 10 root 3, blah, blah, blah. And so we find the individual areas of these triangles, and this is 50. Okay, wait, I should use a different. This is 50. And because it's 10, 10 root 3, we know that this is going to be 50 root 3. Same logic. This is 50 root 3 as well. And this, oh wait, no, that's part of the pentagon. And so now we find the area of the total rectangle. Just 10 root 3 plus 10 squared. And we learned that's a square actually. So you get 300 plus 200 root 3 plus 100. And this equals to 400 plus 200 root 3. And now we subtract all these sides, and we subtract 100 root 3. And then we subtract 50. And we get 350 plus 100 root 3. And then we put this into a calculator. And we get 523 because it says rounded to the nearest whole number. And so that's our answer.